This section examines variable intake manifold systems. The air intake manifold for an EFI multi-point engine normally has long branches of equal length. The long branches increase the pulsing effect of the airflow in each pipe and help charge the cylinders. The more air drawn into the cylinder, the denser is the air-fuel mixture when the inlet valve closes. And it's this density of the air-fuel mixture that determines how much pressure develops in the cylinder during combustion, and the level of thrust on the piston to turn the crankshaft. The characteristic torque curve of a naturally aspirated engine depends mainly on how the engine's mean pressure changes across the RPM band. The design of the inlet system largely determines the mass of air that can be drawn into a cylinder at a given engine speed. So that means the inlet system largely determines the engine's torque curve. In general, a long intake manifold produces high torque at lower engine RPM, and higher torque is obtained at higher engine RPM with a shorter intake manifold. Manifolds that respond to changes in engine load and speed by changing their effective length are called variable inertia or intake charging systems. They can have controlling valves operated by the engine management system, which can extend the primary type manifold into 2 or 3 stages. The primary section is made long and narrow for the low range of RPM. The secondary section is shorter and wider for the high range of RPM. This combination maintains a high-speed airflow in the system. The 3-stage manifold extends the torque curve so that the torque curves overlap each other as advantageously as possible.